Earth Systems 3209, Unit 4, The Forces Within Earth. Book references can be seen in Chapters 4, Chapter 15, Chapter 16, Chapter 19, and Appendix A and Appendix B in the Curriculum Guide. Unit 4, Topic 1.2. This topic will look at evidence supporting continental drift. The focus will be on outlining and describing evidence to support continental drift. When looking at continental drift, Alfred Wegener's theory of continental drift states that approximately 200 million years ago, a supercontinent called Pangaea started to break apart. Laurasia was formed in the north, and Gondwanaland was formed in the south. Over the past 150 million years, these landmasses split apart and drifted to their present positions that we see today. Since the early 1900s to mid-1900s, much evidence has been collected to support the theory of continental drift and plate tectonics. You can see these text references in your textbook on page 515 to 519. When studying continental drift, we look at the various pieces of evidence to support the theory. The first piece of evidence is the fit of the continents. Continental coastlines appear to fit closely together. For example, when we look at South America and Africa. So if you look to the diagram to the right, we notice that South America and Africa are two continents whose coastlines fit very closely together. The continents in the north, we look at North America and the eastern part or western part of Europe. These continents, once put back together, tend to fit very closely also. With further investigation of continental coastlines, a scientist named Alexander de Toy suggested that the continental shelves would fit better because of the absence of erosion beneath the oceans. So when we look at South America and Africa again, we notice that the continents do fit close together. But if we look at the southern part of South America where it comes in contact with Africa, there are gaps. But if we can put the continental coastlines or continental margins closer together, we notice that this blue area that's underneath the ocean tends to fit closer with the continental margin on the neighboring continent. We see very little gaps between the actual continental margins when they come together. And in some places, we notice little bits of red in between the continents here. This is where we have a little bit of overlap, and that could be due to sedimentation that's occurred over millions of years. So Alexander de Toy said, when you fit the continents back together, yes, the coastlines do fit well, but if you look at the continental margins, they actually fit better than the coastlines themselves. So that's the first piece of evidence to support continental drift, the fit of the continents. The second piece of evidence to support continental drift is fossil correlation. Wegener and other scientists had proof of similar organisms that existed on neighboring continents. And in this case, we will focus on South America and Africa once more. When we look at South America and Africa, when they're fit together, not only do their coastlines tend to fit together pretty closely, but we also see evidence of fossils in the rocks on neighboring continents that are continuous across both continents. Fossil evidence of a fern plant called a Glossopteris and an aquatic reptile called the Mosasaurus provided the best evidence that the continents were once together. Now if we look at the diagram to the right, we will see that the green plant that's continuous from South America to Africa, namely the Glossopteris, will be continuous on neighboring continents. And also a freshwater aquatic reptile known as the Mosasaurus were basically found at similar locations on neighboring continents. So the fossil correlation is the second piece of evidence that supports the ideas put forth by Wegener of continental drift. If we look at all the continents that make up Gondwanaland in the southern hemisphere, we will notice that the brown area here, stretching from South America to Africa. We also have a darker brown area, which stretches from Africa across to India and down in Antarctica. And we have the gloss paratus, which actually stretches from South America, Africa, India, South America, or Antarctica, and also Australia. And then we have the Mesosaurus, which is the blue area, that stretches across from South America to Africa. These four regions show similar fossil types that are present on all land masses that make up all the continents that were thought to be the southern portion of Pangaea. So this fossil evidence in the rocks, seen stretching from one continent to the next, is overwhelming evidence to support the idea that the continents were once together as one supercontinent called Pangaea. The third piece of evidence focuses on rock types and structural similarities, such as mountain chains. Scientists also noted that even though the continents fit together, the overall picture has to be continuous from one continent to another. This picture included the type of rock on the neighboring continents and structural similarities such as mountains. For example, the Appalachian Mountains, or in the diagram to the right, there's a mountain chain that runs from the northern portion of South America over into central portion of Africa. And in the central portion of Africa is where you would find Mount Tongariro. If we look at the southern portion of South America and Africa, we see similar rock types. There are rock types that contain fossils that are the same type of rock that are located on neighboring portions of the continents. And you also see a little green area here, which would also suggest a rock type that is continuous from South America over to Africa. So a third piece of evidence that supported the continental drift theory centers around looking at the different rock types, which are continuous from one continent to the next, and also focusing on mountain ranges that basically travel to the coastline of one continent only to pick up in a similar place in the neighboring continent once the continents are put back together. Such a mountain range is seen on the northern part of South America and Africa, as we see in the diagram to the right. So rock types and structural similarities like mountains are continuous from one continent to the next, and this provided evidence to support the plate tectonic theory. Another piece of evidence would be ancient climates, or what's commonly called paleoclimates. Glacial deposits were found in South America, Africa, India, and Australia. These continents are presently not in cold climates, therefore must have been in colder climates in the past, and the continents later moved to the positions they are presently seen in today. So if we look at the diagram to the right, we will notice that in the middle of the southern portion of Africa, the S with the dot represents the South Pole. And if we look at the South Pole, all of the continents in the southern portion of Pangaea were centered around the South Pole. That is South America, Africa, a portion of India was close, Antarctica, and Australia. So all these continents that were centered around the South Pole, according to Wegener's theory of continental drift and the formation of Pangaea, would suggest and explain why we have a lot of glacial deposits found in South America and the southern portion of Africa, in India, and Australia. And most of these continents now, at present time, are not located anywhere near the South Pole or in cold climates. So therefore, to explain why they would contain glacial deposits could be explained by the continents once lived or once existed in a cold environment, such as rest surrounding the South Pole. Present day, South America is located near the equator. Africa is located near the equator. India moved north of the equator into the bottom of Asia, and Australia also moved north. The only continent that actually exists near the South Pole at present time would be Antarctica. So ancient climates provided evidence to support the idea that at one time all the continents were together as a supercontinent, and the southern portion of this supercontinent was very close and existed over the South Pole. Let's look at some examples from past exams. First question reads, which of the following scientists contributed the greatest to the continental drift theory? So if we look at the continental drift theory, we see that Alfred Wegener, proposed the continental drift theory, and his major supporter to explain why the continents moved was Arthur Holmes, which actually proposed the mechanism to explain why continental plates move. So the answer to this question would be B. Wegener and Holmes are two supporters of the continental drift theory. Next question reads, which two continental plates appear to have the best fit along their coastlines? If we go back and look at the previous question, we see that South America and Africa, when put together, their coastlines will fit really, really close together. So the answer to this question would be D, South America and Africa. The coastlines of South America and Africa, when placed close together, their coastlines fit extremely well. And if you look at further, as Alexander de Toy suggested, their actual continental margins fit even better. Example 2 reads, which scientist proposed the continental drift theory? And the answer here would be Alfred Wegener. Harry Hess was responsible for suggesting seafloor spreading. Tuzo Wilson contributed to the plate tectonic theory, namely hotspots in the mantle and transform faults on the ocean floor. And Robert Dietz was one of the scientists responsible for putting forth magnetic reversals. So the answer to this question would be Alfred Wegener. He's the person that proposed continental drift theory. Your turn. Take the time and complete the following question. You can pause your recording now so you can prepare your answer, and the answer to the following question will follow. The question reads, describe two pieces of evidence that Wegener used to support the theory of continental drift. So to answer this question, we could use any two of the four following pieces of evidence. First piece of evidence could be the fit of the continents. When we put the continents back together in close proximity to make up the supercontinent Pangaea, the actual coastlines will match up. But as Alexander de Toy suggested, if we look closely at the continental margins, namely the continental shelves that are located beneath the oceans, which have eroded very little, unlike the coastlines, the continental shelves will even fit even better than the coastlines. The second piece of evidence that we could look at will be fossil correlation. Once all the continents are reassembled to form the former supercontinent Pangaea, we see fossils that actually match up with the same type of fossil, same type and same age on neighboring continents. And this is most commonly seen, or best seen, when you put South America and Africa back to close proximity. The third piece of evidence will be paleoclimatic evidence. When we put the continents back to match up like they did when they existed as Pangaea, climates from one continent to a neighboring continent would be similar. And evidence is preserved in rocks that actually suggest that the climate was similar, such as glacial evidence seen in all the southern continents that once existed as Pangea. So South America, Africa, India, Australia, and Antarctica all contain glacial evidence preserved in the rocks, even though that the majority of these continents now do not exist in a cold environment. And a fourth piece of evidence that you could use would be the matching up of rock types and mountains on neighboring continents. Once the continents come back to close proximity to one another, rock types and mountain chains are continuous from the edge of one continent to the border of the next continent, the neighboring continent. In summary, when we look at the plate tectonic theory, evidence to support Wegener's theory include fit of the continents, fossil correlation, rock types and structural similarities such as mountains, and ancient climates. All four of these pieces of evidence provide overwhelming evidence that the continents that presently exist where they are today were not always at those locations, and they once existed as one big supercontinent, which Wegener referred to as Pangea.